Hi. Now, we always talk about instant delivery to customers with minimal waste, but how close can we actually get to this in traditional construction? It's not. Yes, we can reduce time and cost, we can improve productivity and quality, but construction sites will remain crowded with people, equipment, material, and most importantly, construction designs are becoming more and more sophisticated, forcing us to build complex formworks that are really expensive and time-consuming, which is why we shall admit that traditional construction has been pushed to its limits and we need change. And in my opinion, automation is always a solution, which is why my name is Fatima and I came here with my professor, Dr. Farouk Hamze, from the American University of Beirut, in order to show you how 3D printing serves lean construction. Now, if you're not familiar with 3D concrete printing, it's an additive manufacturing technique. It's not working.
I have a video.
It's not working. It's an additive manufacturing technique that transforms 3D CAD models into built structures by depositing concrete one layer after another. Okay, there was a video, but it's not working for some reason. Can you fix it?
Where is it? Here? This one here?
You have to look in the mouse and try to find it.
No, it's in the slide before.
See that video?
The slide before. Let's see.
This one here? We can do in the meantime.
So this is technically how 3D concrete printing works, and it's how it deposits concrete one layer after another in order to build a structure. Can you go to the view, please? Now let's talk about the significance of 3D printing. Many projects around the world were built in very short time periods and for really low cost. And they actually had the headlines of the news, and many of you have probably heard of the 10 houses that were built in China in only 24 hours, or even the house that was built in Russia in 24 hours, or the office that was built in Dubai using 3D concrete printing. And this fame is mainly due to the many advantages the technology has. First, it requires much less construction duration than traditional construction. Second, it requires less cost since it requires less labor, it produces less waste, and finally it allows structural customization in order to save material. Finally, it allows building high-cost curved structures and sophisticated architectures that are really hard and sometimes even impossible to build using any other ways. So it supports the three pillars of the lean ideal, which are time, cost, and value. Thus, the purpose of this research was to show how 3D concrete printing embodies the lean philosophy. And for this, we compared 3D concrete printing to traditional construction by first conducting a literature review in order to explore the different contributions that 3D printing has realized in the construction industry so far. Then, we collected data from actual construction projects. Then, we drew the value stream maps for both methods, the traditional method and 3D concrete printing of a residential house. Finally, we compared the maps and we made some further analysis. Now, we used this structure for our study. It has a footprint of 100 meters squared. a wall thickness of 20 centimeters and a clear height of 3 meters. For the traditional construction, we considered that all the walls are made of reinforced concrete, while post-tensioning was used in 3D printing. Now, for the traditional construction, the data was based on the production values we collected from the projects. As for 3D printing, we used an assumed velocity of 15 centimeters per second, which is the printing velocity. Now, for a sound comparison, we considered that the roof is made of precast pre-slabs overlaid with 10 centimeters of concrete. Now, for the conventional construction, the unit of flow we used was 5 by 3 meters for the construction of vertical elements, which is equivalent to a wall, and 5 by 5 meters for the construction of horizontal element, which is equivalent to a room's roof. We got this value stream map. Now, I'm not gonna go into the calculation detail, but the process consists of rebar installation, formwork installation, concrete pouring, formwork removal, pre-slab installation, and finally top slab concreting. We got a production lead time of 14.7 days and a processing time of 14 days. Now, for 3D printing, choosing a single unit flow was more problematic since the whole thing is built together. So we divided the printing process into 3 stages. The first stage consists of printing concrete until the bottom of the windows. The second stage consists of printing concrete until the top of the doors and windows. This is followed by installation of lintels, and finally we completed the printing process. Now we got this value stream map. These are the stages I already talked about. They are followed by post-tensioning, then grouting, pre-slab installation, and finally top slab concreting. We got a production lead time that is equal to the processing time and is equal to 5.75 days. Now, after we compared the maps and made some analysis, we made some conclusions. First, the traditional method takes around 15 days, while 3D printing takes around 6 days. This means we have 60% reduction in time. We can further reduce the 6 days since 3 out of 6 days were allocated for concrete to harden before post-tensioning is done. Now, regarding waste, you could notice that the production lead time for the traditional method was greater than the actual processing time with 1 day difference. This difference was eliminated in 3D printing, and it is considered waste from a lean perspective. Moreover, the traditional method requires a lot of movement of employees in order to transport material and some equipment, or the large number of rebars, and these movements are greatly reduced and sometimes even eliminated in 3D printing, and this is less waste. Finally, 3D printing reduces another type of waste, which is rework, and I'll explain this in a while. Now, regarding quality, many of the problems that formwork usually causes to 3D printing, such as honeycombing, air holes, sand streaks, are eliminated in 3D printing since it's a form-free construction. And moreover, problems are visible since we don't have forms, and thus they can be easily spotted and directly treated, unlike in traditional construction, where defects are usually hidden and are only revealed after we strip the forms. So we'll have less rework. And in fact, in 3D printing, we have to stop in order to fix the problems, because one defective layer of concrete will disrupt the whole pattern of all the subsequent layers. And so we have a built-in jidoka. Finally, there are not enough research on cost, but there are many advantages that we cannot deny. First, it requires much less workers. For example, one operator of the printer can replace all the workers needed for shuttering and concrete works. Second, some materials are not needed, such as forms, their accessories. Some activities are not needed, such as concrete vibration, some finishing operations. And finally, 3D printing requires much shorter construction duration. This means less overhead, less rental costs, less worker cost, labor cost. So we have lower cost, less waste, better quality, and less time. And 3D printing, as I said before, embodies many principles of the lean construction, such as basing management decisions on long-term philosophy, stopping when there is a quality problem, using pull system to avoid overproduction, create process flow to surface problems, respect, develop, challenge your people, and finally making decisions slowly and printing rapidly. In conclusion, a wide research aims at integrating lean into the construction industry, but reducing time and cost is very challenging. And yes, we can improve quality, but it usually occurs at the expense of time and cost. So I think that automation may change everything, and we're not very far from automating our construction industry. We have printers, we have robots, we have drones, and although they are still in infancy, they are very promising, and they can greatly facilitate the integration of lean into construction and moving us closer and closer to the lean idea. Thank you.
Question.
Yes.
Last time again, if you use 3D printing, do you think that it's to solve a wrong problem? Because if we optimize the production of concrete walls, prefabricated wall, we can have the same lead time with 3D printing. Because if we go back in the previous presentation, we have a lot of waste in a classical way. If we reduce the waste, we can have the same lead time without high investment in a 3D robot.
Okay, but the greatest advantage of 3D printing is that it's in situ construction. So you bring the printer on site and then you print the whole thing together in only 24 hours. Unlike precast, where it's more like mass manufacturing precast, because you'll build all the components and then ship them on site, and you'll have transportation costs and everything else. So 3D printing has many advantages over precast, but in this time you can integrate everything together to make them better than traditional construction. And after many years, we'll probably have 3D printing all of our houses. For example, Dubai is, they say that around 30% of their construction will be 3D printed by 2030, I guess. And 30.
And one more thing is the complex shapes. More complex shapes, you have crazy shapes for buildings. You know, architects are getting more crazy. The more we make the case of 3D. Okay. If you're using the traditional ones, I think the traditional precast is much cheaper, and already it's optimized. Like the precast industry is optimized in the world. So it gives you a very good solution. And now once you go into something which is really shapes that are crazy shapes, this is what they're coming with new design. Then this is when it's completely easier. I agree.
Yes.
I have two questions. I'm not sure if you showed the prototype you made. You have a sort of sample
Of the printer?
We haven't printed the house.
Oh, but it's just a
I haven't printed the house. This is just a very sweet map.
Oh.
We haven't printed the house. So the
This
that
is-
we have now is this it's a lab size. It's a lab size printer. So it's like 1.5 meter by 1.5 meter.
We printed a wall. We actually printed a wall in our university.
and the finishing. Sorry.
I was thinking if you printed this.
Yeah. You can print intricate things. You can print simple things with it. So
That's all right.
Any other question?
Okay, 2 more minutes. A little less.
Yes?
I think Lane talks a lot about looking at not just the value-adding elements, which I think you've done very much here, but at all the ways that surround it, and says, be very cautious about using technological solutions to solve problems where the waste very often can be solved with much more simple things. So I think my concern here is, are we just automating the value adding process, but not relating to the actual waste around them? Because I often hear people say, no, all the construction needs is ERP. And I don't think that's necessarily right, because the technological solution in itself will not do the same thing. So how are you going to avoid that with 3D printing?
The thing is, the technology does not produce waste from the first place.
Okay.
Because you're printing concrete, you're only printing concrete.
Material waste.
Yeah.
Okay.
You don't even have, you have a small amount of material waste because everything is planned and everything is optimized on computers. So Lean tells us to make decisions slowly and then implement rapidly, and this is exactly what 3D printing is about, because you spend a lot of time designing the structure and optimizing everything. It allows you to customize the structure in order to save material, and you can actually manipulate the cost of the structure you want. And this is why it does not produce a lot of waste. So we don't have the problem from the first place.
To your question, I'm not involved in this research, but I got the impression that this is a sort of synergy between technology and principles. And I think I tend to agree with you, but I think this is not just about.
I'm sorry to say this, but it's time's up for this session.